Astaxanthin is a carotenoid xanthophyll found in various microorganisms and marine animals. It is a red fat soluble pigment that lacks provitamin A activity in human body. Our research uses Littopenaus vanamei shrimp shell waste as a source of astaxanthin for anti-diabetes and anti-inflammatory. Shrimp shells that have been dried are mashed to a powder, then extracted using the maceration method. The solvent used was 70 ethanol and macerated for 3 days. After that, it is stirred so that all the powder can come into contact with the solvent. After 3 days, it is squeezed and then filtered using filter paper to separate the solids or shrimp shell samples from the solvent. The solution obtained was then evaporated using a rotary evaporator at a temperature of 40 degrees with a rotating speed of 55 rpm. The following was a picture of astaxanthin identification using thin layer chromatography. Purification using column chromatography. Silica gel was used as a stationary phase, and petroleum ether and ethanol was used as a mobile phase. The fraction is then collected using a test tube and then evaporated at room temperature. Anti-diabetic and anti-inflammatory preclinical test using Ratus norvegicus rats. The first was blood collection of white rats through the tail veins by cutting off the end of the rat's tail. Then, check the blood glucose using a glucometer. After checking blood glucose, rats were injected intraperitoneally with streptozotocin. Streptozotocin works to increase blood glucose in rats. After that, the mice were given the treatment orally. One of the treatments was the astaxanthin extract from the shrimp shells. The next step was carrageenan injection for inflammation induction. 0.1 ml of carrageenan 1% was injected into the subplantar tissues of the hind paw of the rats. After carrageenan injection, rat blood was placed on a glass object and a peripheral blood smear was made to calculate the differential leukocytes. The next step was to stain the blood cells so they can be observed under a microscope. The first step, the blood smear, was put in methanol for 5 minutes, dried, then stained with Vinsa and left for 55 minutes. Then rinse with distilled water, dried again and ready to be observed. The blood smear was viewed under a microscope at 100 times magnification using immersion oil. The number of neutrophils and lymphocytes per 100 leukocyte cells was counted using a hand counter.